Hi everyone. We've had some questions, quite a few questions on the discussion board about whether or not the difference between the present value calculation using the present value tables and a formula or a calculator, is that a problem? And I'm going to use the question from the Spring 2010 paper to, I suppose, provide information as to why it's not a problem and how that comes about. So what we're looking at here is a situation where we have a set of cash flows, and those cash flows are going to be a 4% annual coupon, and there's 3 of them, and the face value of the note is $10 million. Now remember, the face isn't necessarily how much you received at the time of issue. That is how much that the company who borrows it has to repay at the end of it all. In this case, how much they raised was $9.7 odd million. So what we've got is a situation where you have timeline and you've got $400,000 being paid at the end of time 1, $400,000 being paid at the end of time 2, and $10,400,000 being paid at the end of time 3. So first of all, we have an annuity of $400,000 for 3 periods. So using the present value of an annuity table, and this is the one that was provided in the exam, we go down to 3 years, we look across at 6%. Now we use 6% because that is what the market rate is paying. Once you've figured out the cash flow, you can ignore the coupon rate, so you can almost scratch that out. We don't need that number at this point. And comparing those two, we end up with 2.673. Now doing the same thing, except looking at the present value of $1, we go to 3 years, and we go to 6%, and we find we have a present value factor of 0.840. So those are the two factors that we have in place. Remind yourself of those just for a second, because we're going to be getting rid of those tables to give ourselves a little bit more room. So we've got rid of them, but we had 2.6. Sorry, my bad. We had 2.673 and we had 0.840. Multiply that by $400,000, gives you 106,900. Multiply that by the final payment, the face of $10 million, gives you $8,400,000. $8,400,000. Add them together and you end up with 9,469,200. Which, if you have the solutions in front of you, is different to what the solution is, and the solution we have provided is 9,465,398, which is a difference of about $3,802. In terms of materiality, $3,800 seems like a bit, but if you work out the percentage that is, you're looking at there is no problem. But just to explain further as to how this has come about, we're just going to focus on this present value factor for a second. So that present value factor, I'll just write it in here, is the present value of $1. So it's that future cash flow of 1, and we're looking at 6%. So divided by 1.06 to the 3. And when we calculate that all out, what we end up with is 0.83961928, and it probably keeps going. Not much different to 0.840 that we had, and you can see it's just being rounded up. But when you're talking that on a base of $10 million, that becomes quite a substantial difference, and it actually works out to be a difference of about $3,807. So it's simply caused by the rounding differences and getting rid of all that difference there, and that's all it is. If you do it using the present value formula or financial calculator, you'll get pretty much a spot on number. If you use the tables, it will be rounded, but we'll accept that, and there's not a problem with that at all. I hope that helps. Thank you.